Hello, this is a video on a simple pendulum that is swinging about its pivot point, and we're going to use rigid dynamics to simulate the motion and then obtain this peak force of 24.9 newtons, and then apply that as a bearing load in the static structural model and obtain the stress. So the rest of the video is to see how that's done, and we're going to just redo it in Workbench here. So pulling out a rigid dynamics and then importing the pendulum solid body and opening up rigid dynamics. Here's the link in rigid dynamics, and we want to insert a connections folder so we can insert a joint, and that joint's going to be to ground, and it's going to be a revolute, and it's going to use this face to be the mobile. The other item we need is standard Earth gravity. It's going to be in the Y direction, and we're going to just put in a deformation and a total force from the revolute, which can drag and drop to get that total force, and we can just solve that. Rigid dynamics solves very quickly compared with static structural or transient structural, so we're finished, and it's got the full motion, and it's got the probe of the total force going through that revolute joint, and 24.917 is the number we're going to remember to take into the next phase. The next phase is to apply that load to a static structural model, and we'll bring the same geometry in, but we're going to mesh it a little differently. So we'll see how that looks in the next section. Static structural has opened, and we need to tell it to use a reasonably small sized mesh. We're going to apply some loads. Under the environment tab, we want a bearing load, which distributes a force that we can select onto this geometry, and the force was the value from the rigid dynamics 24.917. The direction is along this, which will flip, and what we need is a boundary condition that holds this fixed without adding any stiffness, and we're going to set the analysis to be an inertia relief analysis. What that means is that the solver will figure out the acceleration it needs to apply in to the model to balance the force that's been applied to this. And for the solver to solve, we just need a remote displacement, which we can apply to any piece of geometry, and just set 6 degrees of freedom to 0. And once we've done that, the solver will have no issue solving. So we'll set ourselves up to see some stress and go ahead and solve. And here is our stress with an enormous auto scale, but back to a true scale. That is the stress around the hole for a bearing load going in this direction of 24.917. newtons that was found from the rigid dynamics dynamic analysis. All right, hope you enjoyed that. Thanks for watching.